Hello students. So in this video, we are going to see the next machine tool that is used for machining or metal cutting process, that is milling machine. So this is the topic in case of introduction to manufacturing. So we'll see this milling machine, then specification of milling machine, types of milling machine, the basic elements or basic parts of milling machine. So let us start with the first one. What is meant by milling? So milling is the process of removing metal from the workpiece by feeding it past a rotating tool, which is called as a milling cutter. So in case of milling machine, we feed the cutter. That cutter is called as milling cutter. So the cutter generally which is used or provided here in case of milling machine, it is a multi-point tooth, or it is also a multi-point or multiple tooth, or we can say multi-point cutting tooth is there. So that can produce a number of chips in one revolution. So because having a number of multiple points, cutting points, so it produces number of chips in one revolution of the workpiece rotation. So if you see in case of milling, the principle is there. So the basic milling process is shown in this figure. So if you see, we have a cutting tool, that is a milling tool is there, and we have a workpiece. So the basic milling process is shown in this figure. Here, the cutting edges are also arranged in circular way. So all these cutting edges, it is arranged in a circular way. That is the multi-point cutting tool. So the milling process is most widely used in machining of variety of shapes. In case of workpiece, including all materials like cast iron, steel, it may be non-ferrous metals, non-metals, etc. So all types of materials, it can be machining operation, it can be done on these all types of materials. So the process of milling is to produce a good surface finish as well as the accuracy of dimension. It is a good as compared to other types of machining process like lathe machine, or we have a drilling machine or any other machine. So it has a very good surface finish as well as it has very dimensional accuracy as compared to other machines. So the milling machines, they are provided with all necessary arrangement for giving a rotary motion, then for milling cutter, then workpiece clamping, or we can say positioning and feeding of the past the work milling cutter. So all these arrangement, it can be done in a milling machine. So now there are two types of milling. One is up milling and another one is a down milling. Now if you see, these are the milling cutters, that is milling tool is used. So it has a circular, we can say a circular edges are there. They are arranged in cutting edges. They are arranged in circular ways. So this is a multi-point cutting tool. That is the milling cutter. Now this is another example. So there are mainly two types of milling processes there. One is up milling and down milling. So we'll see this all types, what is meant by up milling, down milling in the operations which is performed on milling machine. So this is the milling machine, or I can say that is the machine tool which is used for milling operation. Now, if you see, there are basic parts of this milling machine. Now there are two types of main milling machine. One is called as horizontal milling machine and another one is vertical milling machine. So we'll see the parts of first horizontal milling machine, and then we have a vertical milling machine. So instead of this R bar, in vertical milling machine, we have a spindle, and clutch, drill bit, spindle, and chuck is there, by which we can fix the milling cutter into this spindle than arbor. So in case of horizontal machine, other than arbor or arbor bracket, all other parts are same. So if you see horizontal machine, it has two types of views we have seen here. One is front view and another one is side view. So what are the parts of this horizontal milling machine? The first part is base. So we have this base part. Second one is we have this column part. Third, we have this overarm. Then we have arbor bracket is there. So in that bracket, the arbor is fixed, and in that arbor, the cutting tool, it is fixed on that arbor. So as if you see in horizontal milling machine, so the cutting tool, or you can say this, it has a horizontal axis of this arbor. So it is called as a horizontal milling machine. Now we have a machine voice where we can fix a part or workpiece where this milling operation it can be done. Now we have cross transverse handle. Then this is a knee. Then this is vertical transverse handle. So we can have a vertical transverse motion, that is this direction motion, and so also we have a horizontal transverse motion. So this motion, both motions can be there in case of this milling machine. So here there is a knee which is provided. On this knee, the transverse handle is there, and on that knee, the work table is again fixed in this so that the workpiece can be fixed. So this is the layout which consists of all these parts. Okay. So now we will see the different parts of horizontal milling machine. So first part, it is called as a base. So this is the base of this horizontal milling machine. So the base is the foundation of the milling machines. Hence, it supports all other parts of the milling machines. Like it may supports the column, then we can say overarm, then arbor bracket, work table, and all that. Thus, knee, saddle, all these parts, they are supported by means of this base. Now, it is a rigid casting. Base is a rigid casting, and it can be bolted to the floor. So much care is taken to make the top and bottom surface of base extremely smooth and accurate. Now this is used for a machining. So top surface as well as the base surface, both should be have top and bottom surface of the base. It should be have a smooth as well as accurate. Now the base of certain milling machine are hollow, and if we make this base hollow, we can use this machine, this milling machine, or we can say base, as a reservoir for cutting fluid. So this cutting fluid we can provide by using this base, and it will act as a reservoir to store that cutting fluid. So this is the first part, base. Now second part is the column. So column is the main structure of milling machine, and all other parts is attached to this column part. Now generally column, it has a box shaped structure which houses the motor drive. It may be an electric motor drive, and also a mechanism of the milling machine, that is feed mechanism is there, or you can say a drive mechanism is there. So that will is there inside this column. Now for adding rigidity to this structure, column is provided with heavy ribbed support inside. So the front side of the column has accurately machined. So this front side, it is accurately machined, smooth surface and it's called as a column face. Okay, and the column face is provided with a guide wedge. So this column face, it has a guide wedge. So we can say movement takes place along this guide wedge. So that is called as a column face, and that column face is provided with the guide wedge for any vertical movement along with it. The top of the column is also machined accurately, and it also uses to hold the overarm. Okay, so front face and the top face both are accurately machined so that it will hold, or we can say it will provided with a guide wedge for vertical movement, or it will hold and guide the overarm also. Now next part, in case of this any milling machine, it is the knee. So knee is a overhanging part. So here the knee is there. It is a overhanging part which projects from the column. So one end of this knee is connected to this column, or we can project from this column. The knee, it slides along the guide wedge of the column face, either in up and down. So all this knee assembly or knee parts, it can slide along this column part in upward direction or downward direction. Now the knee is firmly supported by a elevating screw, and this is mounted on a base. So we have a elevating screw by which this knee is mounted on a base. Now the elevating screw serves to raise and lower the knee for the positioning of workpiece with respect to milling cutter. So generally the knee of milling machine houses two parts mainly. One is feed mechanism. It may be a manual feeding or it may be a power feeding. So it has a feed mechanism and control of the table. So this is the main function of the knee. So this control of the table uses to hold the workpiece. The knee is also provided with guide wedge on its top also. So in top, we have this guide wedge where the saddle is fixed along this knee. So these are the other parts. Now we'll see, these are the base column and knee part. Now next part is the saddle. As like lathe machine, this milling machine is also having a saddle. Now saddle in milling machine is fixed on knee of the machine. So this is the saddle part. It is fixed on this knee. And this saddle, it can slide transversely along the guide wedge. So as knee has a guide wedge, so saddle can move along the transverse direction. That is in this direction, that is XY direction. So the saddle, it can slide transversely along the guide wedge in the top surface of the knee. Now this saddle is provided with a graduations for exact movement, and it can be operated either manually, as in this figure. This can be operated manually, or sometimes it can be operated by using power. So this is the saddle part. Next part is the table, that is the work table. The table rests on saddle, and this can be sides longitudinally. Okay, so this can be sides along this direction, longitudinal direction. And also the table can move transversely by using saddle. So both motion is there. So the transverse motion as well as we can say the longitudinal motion. So both motions that can be possible by using this saddle and work table. So the table has accurately finished top surface. So top surface of this table is accurately finished, and it is provided with some T-slot for clamping of the workpiece on this work table. And any other work holding devices, or we can say fixtures, by which the workpiece or job, it can be fixed on this work table. Now the longitudinal movement of table, it is limited by using with the help of this trip dock, which is fixed on the side of the table. So we can limit this longitudinal movement. So based on the machine type, the table can also have a provision for the revolving, or we can say swiveling and tilting also. Sometimes this work table, it may tilt, or sometimes this work table, it may rotate to some angle. So that both motion, it can be have based on the machine type. So this is the work table. Now the next is spindle and arbor. Now in case of horizontal milling machine, we have arbor. In case of vertical milling machine, we have spindle. That is the main difference between this horizontal milling machine and vertical milling machine. So if you see, the spindle is a main driving element which receives power from motor through the arrangement of either belt drive or gear drive or through clutches. And the spindle, it rotates and transmits the power to the arbor, or we can say there is a stub arbor. So we have a spindle, and in that that will rotate or transmit the power to the arbor. Now the cutter, it may also directly mounted on a spindle nose, or sometimes the cutter is mounted on this arbor. It is depend on which type of machine is there, horizontal milling machine or vertical milling machine. Now arbor, it is a part, so it is accurately machined. A shaft like structure is there. So if you see this arbor, it has a shaft like structure which is attached to spindle by fitting one end to the spindle nose, and another end is by using a mounting clamp is there. So that is called as arbor clamp. Now the arbor is used for mounting and rotating the arbor type milling cutters, and the position of these milling cutters along the arbor, it may adjusted using some suitable spacing collars. So the different cutters will be there, and that can be the space is provided between these two cutters. Now the arbor is supported by a front base. So another part is there, so by which arbor is gets supported. That is called as a front brace. Now we have overarm and the front base. Next part is overarm and front base. So overarm is a overhanging arm which is mounted on the top of the column, and that can be moved again in and out by using manual or manually to suitable position. So we can move this overarm. The overarm provides again support to arbor by using the front base. So this part is called as a front brace. So by which it gives supports to this arbor part. So the overarm provides support to the arbor through front base, which is extra support that fitted between knee and arbor. So the front brace has a provision or a slot for adjusting the height of knee. So by using this front base, we can adjust the height of knee with respect to overarm. Okay, so by using this front brace, the distance between this arbor and the knee, it can be maintained. Now, in addition to this principal part, now these are the main principal parts, like overarm is there, spindle and arbor is there, table is there, saddle is there. Then we have a base, column, and knee. So based on these parts or some principal parts, we have other important parts that are used, or we can say accessories are used, like a suitable voice is there. Then we have a dividing head or indexing head is there. So this is important part is there in case of any milling machine, that is dividing head or index head. Then we have some work holding fixtures are there. Then cutting fluid supply arrangement is there. So in addition to this principal part, some extra arrangement that can be possible. Now a number of milling machines attachment that can also available to improve the versatility of this milling machine, or to improve the machining operation, number of machining operation that can be done by using providing extra attachment. Now the common milling machine attachment, it includes the vertical milling machine attachment. So this horizontal milling machine, it can be converted into a vertical milling machine. So by changing this front brace, R-bar and this, we can convert it into a vertical milling machine attachment. Then we have high-speed attachment. Then we have universal spiral attachment is there. Sometimes a rack milling attachment is there. Slotting attachment is there. So slotting also, it can be done by using this milling machine. Then we have gear cutting attachment is there. So by which we can cut gear on this milling machine. And we have rotary table attachment is. So on which we can rotate this work table. So these are the common milling attachment which is used to increase or improve its versatility of the milling machine. So generally these milling machines are used to perform many operations like cleavage in the shaft, or we can say in the rotors. Next, gear teeth. So all types of gear tooth or all types of gears, it can be manufactured by using this milling machine. Then we have spline shaft and different grooves. It can be again formed by using this milling operation. Now we have another machine. It is called as vertical milling machine. So if you see in this vertical milling machine, it is as like a drilling machine. Only difference as we use milling cutter instead of drill bit or drill tool. Instead of here, there is a mill tool. So all other components is almost same as that of horizontal milling machine. So the main difference between this horizontal milling machine and vertical milling machine is the orientation of the tool. So if you see in horizontal milling machine, the tool rotates about the axis around the surface of the part, while in vertical milling machine, the cylindrical tool that rotates on perpendicular to the axis of workpiece. So the workpiece axis is like this, and in vertical, milling axis or mill tool axis is like this. So it is a perpendicular. And in case of horizontal milling machine, the axis is same. So if you see the axis of workpiece and axis of milling cutter, so both axes are parallel to each other. Okay, so that is the main difference between a horizontal milling machine and vertical milling machine. That is the orientation of this machine tool, or you can say milling tool. Now, if you see, we have vertical milling machine. So that is the main difference. If you see here, there is no R-bar is there and overhand arm is there. So instead of, we have a head, as like in case of drilling machine, we have a drill head. Here we have a mill head. So all this electric motor and all that part, it will be provided to here. We have a spindle, and in that spindle, we attach this milling cutter by using chuck, as like in case of drilling machine. All other parts, it is same as that of milling. That is, we have a base. Then we have column. Then knee part is there. So we can lower and we can raise and lower, or it have a movement like this in case of knee. Then we have a saddle. It can move in transverse direction, that is in this direction. Then we have workpiece. This workpiece table, it can be have a rotary motion, that is in this direction, or it can be slides. and the work, or you can say feed, is against this direction as like drill machine, that is perpendicular to the work axis. So workpiece is like this axis, and the milling cutter or milling tool, it is perpendicular to the axis of workpiece. So this is the main difference between horizontal milling machine and vertical milling machine. So this is another example where we have a vertical milling machine. Okay, so only there is no arbor is there. So instead of arbor, we have a spindle. All other parts are same. So if you see in case of this vertical milling machine, axis of spindle is vertical. Okay, so axis of spindle is vertical, but in case of horizontal milling machine, the axis is horizontal. So this axis is vertical, and second one is generally this for vertical milling machine, it is used for operation like slotting, grooving, and the vertical milling machine, it is also used for the operations like drilling, boring, facing, and slotting. So if we replace this milling cutter by using a drill cutter or drilling tools, then we have a drilling operation, boring operation, and facing operation as like a drilling machine. So drilling operations, it can be also done in case of only vertical milling machine, not in horizontal milling machine. It is in vertical milling machine. Now we will see the different specifications and applications of this milling machine. So the milling machines, they are specified based on some criteria. So if you see this criteria, the data regarding dimensions of the workpiece, or we can say work table. Second one is the longitudinal, then data regarding, or you can say dimensions regarding working surface of the table, longitudinal, then cross and vertical travel distance, then based on number of spindles, based on number of speeds, or you can say speed steps, based on spindle nodes number, then based on power ratings, net weight of the milling machine, floor space required. So based on that, the specification of milling machine will be there. So we'll see one of the example, or you can say typical technical specification of this one of the milling machine, that is column and knee type of milling machine. So for example, the model is horizontal. So type of milling machine is horizontal. Then we have working surface. So it is of 1120 by 280. So this is the length of the workpiece, and it work surface or working surface, and this is the width of working surface. Then we have longitudinal transverse, so which is of 558 mm. Then we have cross transverse, it is 228 mm. Then we have vertical transverse, that is 406 mm. Then diameter of spindle nose, so 79 mm. So up to 79 mm of diameter, we can have different types of tools, milling tools that can be fitted. Next one is the length of arbor. So as it is horizontal machine, so we require arbor. So length of arbor is 635 mm. Then maximum swing of tool diameter. So tool diameter, or you can say tool, it can be swing. So that maximum swing is 279 mm. Then we have spindle motor. It is used, which is of 155 kilowatt, and the weight of milling machine is approximately 2000 kg. So these are the some typical technical specifications which is used in column and knee type of horizontal milling. So we'll see the applications of milling machines. So as milling machine consists of horizontal milling machine as well as vertical milling machine. So we'll see the applications. So first application is the milling machines are versatile machines, and that are used for machining the various shapes. Like we can produce flat shape. We can produce contoured surface also. Then surfaces of revolution. Then we can produce internal as well as external threads on this milling machine. Then the helical surfaces of various cross sections, it can be produced by using these milling machines. Next application is the milling machines are used for milling and sinking of dies as well as mold cavity. So to produce dies and mold cavities, we use this milling machine. Next, the milling machine is used to machining the key weights, then wide bottom portion of the T slot, tooth space in case of chain sprocket, that is roller chain sprocket. Then we have a milling machine that is mainly used to manufacture the various types of gears. Okay, so it may be worm gear, bevel gear, spur gear, and helical gears. So all types of gears, they are manufactured by using this milling machine. So these are the applications of milling machines. So in this video, we have seen what is meant by milling machine. What are the types of milling machine? There are mainly two types. One is horizontal milling machine and another one is vertical milling machine. And we have seen the different parts of horizontal milling machine, or we can say milling machine, and the specifications and applications of this milling machine. So this is all about this video, that is the machine tool, that is the milling machine.